This is problem 8-61 from section 8.1.3. Solve each absolute value inequality. In part A, well, both of these actually, we learned to treat these as if they were equations, and then we're going to find the boundary points, and then we're going to test at the end to figure out where we shade and how our symbols go. So we're going to pretend that that's an equal sign. So I really have 2x, or absolute value of 2x plus 1 equals 5. Now the stuff inside here, its absolute value is 5, so it means it has to be 5 away from 0. So either this stuff could be equal to positive 5, that's 5 spaces from 0, or it could equal negative 5, that is also 5 spaces from 0. Alright, so we're going to change the answer, the stuff that it equals, to be both positive and negative and solve those for the boundary points. So if I subtract x, or subtract 1, sorry, I have a 4, divided by 2, I'll get x equals 2 is one of my boundary points. Same thing over here, I'm going to have 2x equals negative 6, divided by 2 gives me x equals negative 3 as a boundary point. So I'm going to draw a number line, and have negative 3 on here, positive 2. And the first thing I want to do is decide if, are they going to be open circles or filled in circles, and we can tell that based on this inequality symbol right here. It says less than, it cannot be equal to, so I cannot exactly equal these numbers, so they're going to be open circles. Now I'm going to test a point, and right in the middle, right here would be a 0, so that's always a good point to test, because that's easy to plug in. So I'm going to plug in, is 2 times 0 plus 1, is that absolute value less than 5? So when I plug that in, I really get the absolute value of 1, which is just 1. Is 1 less than 5? Yes. So I'm going to shade in where 0 would be. So that means we've been writing this, we've wrote this a couple different ways as inequality. Negative 3 is less than x, which is less than 2. That's one possible way to write it. Or we wrote it as two separate things, but we just said and in between. We said x is greater than negative 3 and x is less than 2. So either way, this one you're going to probably see in the book, and this is a little bit more fancy of an answer, a more condensed answer, but the other one is still appropriate too. Okay? So for problem B, we're going to do the same approach here. Let me just, let's kind of move this down here and do part B a little, so we have some more space. For problem B, we're going to treat it just the same and find for the boundary point. So we have 2 times the absolute value of 3x minus 2 is greater than or equal to 10. That was the problem. So I'm going to pretend this is an equal sign. And first thing, I need to get the absolute value by itself before I can start setting it equal to positive and negative. I'm going to divide by 2 on both sides. So I know the absolute value of 3x minus 2 has to equal 5. Or, so that means the stuff in the inside could equal positive 5, or it could equal negative 5. Okay, because it has to be 5 spaces from 0. Both of these numbers are 5 spaces from 0. So now I've solved both of these. So if I add 2, I'll have a 7. This is going to become 7/3 is one of my boundary points. If I solve this one, I'm going to add 2, so I'll have negative 3 divided by 3 gives x negative 1. So those are my two boundary points. Again, I'll make another number line. Make sure you label your number line like the right way, so don't have 7/3 on the left and negative 1 on the right side. We're going to have like 0 would be kind of in here. So now we again decide if they're open circle or closed circle. Originally, this was a greater than or equal to symbol, so it can equal those numbers. So yes, I'm going to have open circle or filled in circles here. And let's test the point 0 again. So it was 2 absolute value of 3 times, let's plug in 0. Is that greater than or equal to 10? So I'm going to have, this is going to be gone, so I have 2 times the absolute value of negative 2, which is basically 4. Is 4 greater than or equal to 10? No. So not shading where 0 is this time, so I'm going to go outsides. We talked about this, when they're outsides, that means or. Some of you had some clever ways to remember that. So I can have x is, write it in red here, we got x is greater than, that's a less than, sorry about that, x is less than -1, or x is greater than, these are equals, greater than or equal to 7/3. Okay, so it can't possibly be in both places at once, that's why we have the word or, and it's going to be going this direction of -1 and including -1, and it's going to be bigger than 7/3 or including 7/3 could be possible. So treat it as you're going to find the boundary point, then plug in a point to test to see where you shade.